Hello everyone. Today I am going to teach you about numericals related to electrochemistry. Numerical number 1. Calculate EMF and delta G0 for the following cell at 298 Kelvin. The cell is Mg plus 2. The concentration of Mg plus 2 is 10 raised to minus 3 molar. Salt bridge. Copper plus 2. Concentration of copper plus 2 ion is 10 raised to minus 4 molar copper. Reduction potential of Mg is equal to minus 2.36 volt and reduction potential of copper E0 copper plus 2 bar copper. Okay, and this reduction potential is standard reduction potential. Okay, standard reduction potential of copper is equal to 0.34 volt. Okay, and the question is EMF or cell potential at this concentration and Gibbs free energy, standard Gibbs free energy delta G0. First of all, we can write the reactions correspond to two half cells. Okay, first write the cell representation Mg plus 2. Concentration of magnesium sulfate or magnesium ion concentration is 10 raised to minus 3 molar. Salt bits, copper plus 2, 10 raised to minus 4 molar, then copper. Okay, and left side is indicating anode, right side of the cell representation is cathode. Okay, these two lines indicate salt bits. Anode, which reaction will take place? Oxidation. So write the first half cell reaction. Mg gives Mg plus 2 electron at anode. Cathode reduction. Copper plus 2 electrons gives copper. Okay, now write the overall reaction. Add left side. Mg Cu plus 2 electron. Mg plus Cu plus 2 plus 2 electron gives right side Mg plus 2 plus 2 electron plus Cu. Okay, 2 electron we can cancel it. Okay, now this is the overall reaction of this electrochemical cell. Okay, and for calculating cell EMF, we need E0 cell. So first step is calculate E0 cell. E0 cell, standard cell potential is equal to reduction potential, standard reduction potential of cathode minus standard reduction potential of anode. Which is cathode? This one. So E0 copper plus 2 copper minus E0 Mg plus 2. Okay, Mg, and don't write Mg plus 2 because we are taking only the reduction potential value. Okay, Mg plus 2 is what? Oxidation, but we are taking the reduction potential value. Then E0 cell is equal to E0 reduction potential of copper plus 2 copper is given 0.34 volt minus reduction potential of Mg plus 2 Mg is what? Minus 2.36 volt. Okay, minus and minus become plus. Then 0.34 volt plus 2.36 volt. What is the value? 2.70 volt. Okay, 2.70 volt is E0 cell. Now we can calculate cell EMF at this concentration by using Nernst equation. What is Nernst equation? Cell EMF or cell potential at any concentration. Okay, cell EMF or cell potential at any concentration is equal to E0 cell minus 0.059 by N log C raised to C D raised to D, okay, D raised to D, A raised to A, B raised to B. Let's see this equation, which is C Mg, D Cu, and this C coefficient 1 is equal to small letter c. Here the coefficient is 1, so small letter d. Then 1 A, 1 B, B. Capital B is equal to Cu plus 2. Small letter b is coefficient 1. Okay. Now we can apply all the values here. E cell equal to E0 cell. E0 cell already calculated. What is E0 cell? 2.70 volt. Okay, 2.70 volt minus 0.059 by N. What is N? Number of electrons involved in oxidation and reduction. 2. Okay. Then log C raised to C. C raised to C means what? Mg plus 2. Concentration of C means concentration of Mg plus 2 raised to C. C means, small letter c means coefficient. Coefficient equal to 1. So concentration of Mg plus 2 raised to 1. Then D is copper. Small letter d is coefficient 1. Divided by A raised to A. A is what? Mg. Concentration of Mg raised to A. Coefficient is 1. Okay. Then B. Copper plus 2 raised to 1. Okay. Then concentration of Cu. Concentration of metal is equal to 1. Concentration of Mg equal to 1. So no need to write copper and Mg because pure state the concentration is taken as 1. So we can cancel these two terms. Cu because it is equal to 1. Mg is equal to 1. Okay. So this term is not required. Okay. Then E cell is equal to 2.70 volt minus 0.059 by 2 log concentration of Mg plus 2. Concentration of magnesium electrolyte solution. Okay. Mg plus 2 means MgSO4, like that electrolyte solution. What is the concentration? 10 raised to minus 3 molar. Okay. Actually here both the concentration are different. Okay. That's why we used Nernst equation. If both are standard, what we can use? E0 cell equal to E0 cathode minus E0 anode. Directly we will get the value. Okay. Here concentration is different, so we can use Nernst equation. Cu plus 2. Okay. Sorry. Mg plus 2 is 10 raised to minus 3. Divided by Cu plus 2. 10 raised to minus 4. Then E cell is equal to 2.70 volt minus 0.059 by 2 is equal to what? 0.029 by 5. So directly you can calculate it. 0.059 by 2 is equal to 0.0295, half of this value. Then log 10 raised to minus 3, 10 raised to minus 4. 10 raised to minus 3, 10 raised to minus 4 become 10 raised to 4 into 10 raised to 4. So minus 3 minus, 10 raised to minus 3, 10 raised to 4. Okay, so it becomes 10 raised to minus 3 plus 4. That is equal to 10 raised to 1. So log 10 raised to 1, log 10. What is log 10? Log 10 is equal to 1. Okay, so E cell equal to 2.70 volt minus 0.029, for log 10 is equal to 1. And the final value after calculation 2.70 minus 0.0295, you can calculate directly or you can use the logarithm table for this calculation. Okay, and the value is 2.67. After calculation we will get 2.67 volt. Clear? The next part of numerical is calculation of standard Gibbs free energy delta G0. Okay, what is the equation for delta G0? Delta G0 equal to minus NFE0 cell. Here N is equal to 2. Okay, valence equal to 2. F is Faraday constant. The Faraday constant value is 96500 coulomb per mole. E0 cell already we calculated in the previous section, and the value is E0 cell is equal to 2.70 volt. Substitute all these values in this equation. Minus 2 N 2 F 96500 into E0 cell is 2.70 volt. Okay, and the final result is minus 5.21 into 10 raised to 5 joule per mole. Okay, and coulomb into volt. Okay, unit coulomb into the volt. Okay, reduction potential, cell potential unit is volt. Coulomb into volt is equal to joule. Okay, so C into V equal to J, then remaining is moles per. So what is the value? Standard Gibbs free energy of this reaction is equal to minus 5.21 into 10 raised to 5 joule per mole. Clear?